Today we're learning about angle measures in circles, and there's 3 new rules that you'll have to learn. So in a previous lesson we talked about how the central angle and the arc measure just match, right? Well, here's the 3 spots where we could position an angle. We could have an angle with its vertex on the edge of the circle, like this angle right here. We could have an angle with its vertex floating somewhere inside the circle. Or we could have an angle with its vertex outside the circle. And there's a different rule for each one, but all the rules are a little bit similar. So we'll go through them one by one and see how you do. The first thing, I drew this kind of wonky alligator because I wanted to teach you the idea of an inscribed angle. An inscribed angle is this blue angle right here that makes up the alligator's mouth. And it's called an inscribed angle because the vertex is on the circle. And so this angle that the alligator has his mouth open to is called the inscribed angle. If you can see, the part of the circle that he's chomping down on is what we call the intercepted arc. So whenever I look at these problems, I kind of look at them as alligator chomps. This first theorem says that the measure of that angle in his jaw is half the measure of its intercepted arc. And the way that I like to write that is like this. The angle equals the arc divided by 2. Let's just do a quick example of that so you can see what I'm talking about. This one down here. So we see that, do you sort of see how this is an angle with its vertex on the circle? It's an inscribed angle that's opening up to this 84-degree arc. And so that angle will be this arc divided by 2. So this angle would be a 42-degree angle. That's the idea with this little theorem. For the next one, you have to do a little bit more work because, well, do you see the angle that they made? Still the vertex is on the circle, but they didn't tell me how big this arc is. But I can just do 360, subtract off the 2 arcs that I do have the measure of. And what would that be? Is that 170 still left? 170 degrees would be left for this arc. So it's actually still a minor arc, 170 degrees. And so this inscribed angle right here would be that arc divided by 2, which is 85 degrees. Now, there's a theorem that, it counts as a separate theorem, but it's really the same idea. Do you see these 2 angles right here? Angle 1 right here, angle 2, it's linear pair, friend. Well, these remind me of the alligator chomps too, because the vertex is on the circle, and angle 1 is just chomping this entire red piece. And angle 2 is chomping, that's a really wide open mouth right there, is just chomping that entire blue arc. So really, the theorem is the same here. The measure of the angle is equal to the intercepted arc divided by 2. Or the angle is half the measure of its intercepted arc. Let's do this last example and make sure that you get that. So the angle that's 117 degrees is the one that comes from this tangent line and this chord. Now if you imagine that as the alligator's mouth, can you see that the arc then that would be inscribed, or intercepted would be this big guy. And since the angle is equal to the arc divided by 2, in this case, we'd have to multiply by 2, right? So we would say that the measure of arc, should we call it FED, would be 2 times 117, is that 234, I think. That would be the measure of this intercepted arc. So that's the first rule. The angle equals the arc divided by 2 only when the vertex is on the edge of the circle. Let's go to the next possibility. If the vertex is in the circle. So here's the new rule. So we see this little vertex on this angle is inside the circle. P.S. Did you realize that that angle 1 right here and this angle over here are the same angle? They're vertical angles. And that's actually sort of related because it actually relies on this arc, DC, and this arc, AB. We have to know the measures of both of those. And so if two chords intersect inside a circle, then the angle measure is equal to the half of the sum. I just think of that as the average. So the sum is where we add them together, and half of that, adding two numbers and dividing by 2, that's the average of them. That's the rule when the vertex of the angle is inside the circle. So if I wanted to find angle X right here, you can see that this side of the angle is chomping down on here, but this other angle, which would be exactly the same, is chopping down on here. So that angle will equal those two arcs added together and divided by 2. And that comes out to 115 degrees. Not too bad. This next one is set up kind of awkwardly. They want me to find this arc measure, and they give me this angle measure, which is weird because that's not really the angle measure I care about. If I knew this angle measure, that might be more useful. But isn't the 102 and this angle measure, those are a linear pair? True? So would that be a 78 degree angle right there? That would add up to 180, right? Which would make this one a 78 degree angle too. And what we learned is that when the vertex is inside the circle, those two arcs that those 78 degree angles are chomping down on, those two arcs are what determines this angle. So my angle is going to equal the arc plus the other arc divided by 2. So this just turns into a fun algebra problem. Subtract the 95. 61 degree arc for arc AB up there. Seems reasonable. So one more time, arc plus arc divided by 2 is what you do when the vertex is inside the circle. The last rule is when the vertex is outside the circle. So there's actually 3 ways that can happen. It can happen with a secant and a tangent and a tangent, or a secant and a secant, but they all have the same rule, and it goes like this. The angle is equal to, do you see the difference? The difference? Half of the difference of the arcs. So instead of going arc plus arc, we do arc minus arc divided by 2. Using that alligator analogy again, can you see that this alligator is getting a chomp on the blue arc and the red arc right there? So we use both of those arc measures to find the measure of this angle. Same thing here. There's 2 arcs. Actually, these 2 arcs, this arc and this arc, make up the entire circle, which is kind of crazy. And let's do an example. So here we have an angle with its vertex outside the circle. So I know that the angle will equal arc minus arc divided by 2. And if you can see which 2 arcs it's chomping down on, it's these 2. Always take the bigger one minus the smaller one. You won't get any negative answers that way, and that's the way that the theorem is supposed to work anyway. And this one comes out to 51 degrees. Not too bad, right? Let's try this other example. The vertex is outside of the circle, so the angle is equal to the bigger arc minus the smaller arc divided by 2. Can you see that those were the 2 arcs I needed to use? Those 2 arcs. Multiply by 2. Add 44. And this arc right here would have a measure of 104 degrees. Nice. That is the end of this first part